problem 986 interval list intersections. So we are given two lists of closed intervals, first list and the second list. So this is just the drawing. So we have the list A with intervals and the list B with intervals. Yeah. So for each of the intervals we have the start and the end, and each list intervals is pairwise disjoint and in sorted order. Yeah, so this means for each of the intervals it is disjointed, so there's no overlap for each of the intervals. As we can see, this is the interval A, there's no overlap, and also for interval B. And let's just check the return. So we're going to return the intersection of these two interval lists. Yeah, it seems it's quite straightforward, like the drawing. So this is just the intervals, and we're going to return such kind of intervals array. Yeah, so before doing the question, let's just read the constraints, because this is very important for us to solve the problem. So the list is going to be 1000, no matter list A or list B. And the list A plus list B are more than or equal to 1. Yeah, and for all the values, it doesn't matter, even though it can be 10 to the power of 9, but it doesn't matter. Yeah, and for the add I should less than start I plus 1. This means there's no intersections for each of the list, and it is disjoint. Yeah, and the start going to be less than the end, and J going to be less than start J plus 1. Yeah, it seems everything's okay. So what is your first idea when you see such kind of problem? Maybe we can think about this problem, because definitely, let me use another color, maybe it's better. Yeah, let me use white. Yeah, so for this problem, definitely we're gonna merge the two lists into one list, and then we're gonna sort it. Yeah, because if you see such problem, maybe you're gonna think about this is a merge intervals problem. So how can we calculate the merge intervals? Of course, we're gonna merge them together and sort it. So after sorting, the intervals will be like this. Yeah. So I just make a drawing like that. So if it is like this after sorting, definitely we can find the intervals. We can find the intersections. So if this is the start, and this is the add, and this is the start prime, and this is the add prime. Yeah. So if this after sorting, this s prime gonna always be less than the s, and if this s prime is more than and equal to e, more than and equal to the end, it means this is the intersections. Yeah, so the intersections are going to be s prime to the minimum of e and e prime. Yeah, so this is how to calculate the intersections. So this is the e, and the next one going to be e prime. Yeah, we just need to put all those intervals inside our result array, and that's going to be the answer. So after each update of the result, we need to check what is the maximum add precision. So the maximum add precision gonna be, so for each of the time we need to update the end. Yeah, so the end gonna be the maximum of the end and the end prime. Yeah, so there are just the two formulas. After we're using two formulas, definitely we can solve it. First of all, for calculating the intervals, we're gonna use the minimum of the e and e prime. And after updating the add precedence, because we don't need to take care of the start precedence after sorting, because we sorted according to the start precedence, we just need to take care of the add precedence. So for example, after updating, the add precedence is going to be the maximum of e and e prime. So it's going to be here. So this is going to be the add precedence. So for the next one, I'm going to check this start prime. If this start prime is less than the end, so this is the end. So now I'm gonna have another interval I want to put it inside. So it's gonna be the it's gonna be this one s prime and the minimum of e and e prime. Yeah, it's the same. This is the e and this is the e prime. This is the intersections. After that, I'm gonna updating the end precedence. So e gonna be the maximum of e and e prime. Yeah. Now let's just start coding. And for Python, the coding gonna be much easier. So we just need to extend. I want to extend the second list to the first list, and after that I'm gonna sort the first list. As list 1 plus list 2 gonna be at least 1 according to here, so I'm gonna prepare a start and end. So this is my start and add prison, it's going to be the first list 0. And then I'm going to check the second. Let me use start and end. Yeah, so for start end in first list starting from 1. So I'm going to check it. Yeah, so if my current start is less than or equal to my previous add, so this means that there is an intersection. So I want to put it inside my result array. So from here, result gonna append an array. So this array, this interval gonna be start from the start prison and gonna be as, yeah, this is my current start prison, and the add prison gonna be the minimum of the and a minimum of e and the end. Yeah. So after that, I need to update the end prison. So the end prison gonna be the maximum of and e. Yeah. So for each of the time. So for the next time, I have a new s and new e, and I'm gonna compare with the start and the end. But I don't need to take care of the start. I only need to take care of the end, because for each of time, my new start gonna always compare with this end. So the start doesn't matter. I just need to update the end. And after that, I can return the result array. Yeah, so this is just a greedy idea to solve the problem, but basically it is the merge intervals. As you can see, it's pretty fast because the time complexity is n log n. So this n actually is list 1 plus list 2. It is 2000. So 2000 times log 2000 is going to be a really small number. So that is why it's so fast. So the time complexity, we're going to say the n log n because the sorting is n log n. And from here, this is just O n. Yeah. Thank you for watching. See you next time.